Hello students, today let's discuss table filling algorithm. To start with, let's know what is a distinguishable state and what is an indistinguishable states. Two states PQ are equivalent if delta of P on W and Q on W both are final or non-final states. Mean to say, if from state P on accepting a string, there is a transition to one final state. The other, like Q on accepting the string W, that also makes a transition to final states. If both make a transition to final state or both make transition to non-final state, then we say they are indistinguishable. But if one goes to a final state and one goes to a non-final state, then we say it is distinguishable. So, knowing distinguishable states and indistinguishable states, let's do the table filling algorithm. So, this transition table is given to us where A is the start state, C, F, I are the final states. So, given this transition table, we will have to construct the staircase. For making this staircase model, what we do is, we leave the first state A and then we do the vertical entries. That is, I leave state A and I start from B to I. For doing the horizontal entries, I leave the last entry. That is, I start with A, I go up to H. So, I have made the staircase now. Then, in the staircase, I mark the final states. In the given transition table, C, F, I are the final states in the vertical entry. C, F, I is not there, because why we are avoiding that is to, avoid redundancy. We are avoiding that state. That is one first state and one last state. We are not entering just to avoid the redundancy. So, C and F are the horizontal entries. Now, C and F are the final states. Now, we will have to make the entries. For making the entries in this staircase, first what we will have to do is, given all the states, we will have to write this separately. That is, A is the accepting states. In this transition table, there are three accepting states, C, F and I. And coming to the non-accepting states, we have A, B, D, E, G and H. And you see this cell is AB, AC, AD, AE and so on. So, whenever there is a transition, that is whenever there is an entry, this one cell is from accepting state and the other one is non-accepting state, we do a marking. Look at AB, this cell is AB. AB, both are in non-accepting, we will not do an entry. What about AC? AC, one is non-accepting, other one is accepting. So, we will do an entry for AC. How about AD? Both are non-accepting. So, the easiest method is, you choose the horizontal, you see the final state and look for the horizontal cells. See, I take this horizontal, that is the row, to make the horizontal entries. So, this is AC. AC, one is here, one is here. So, I can make an entry. Next cell I take is BC. BC also, one is accepting, one is non-accepting. I do an entry. Then I choose this row F. So, what is this cell? This is AF. A, one is non-accepting, other one is accepting. So, I can make an entry. What about this BF? Yes, I can make an entry. CF, both are final. I can't make an entry. DF, one is final, one is non-final. That is, one is accepting, other one is non-accepting. I can make an entry. What is this? EF, one is accepting, other one is non-accepting, yes, I can make an entry. Then come to row I. In row I, what about this? This is AI. Yes, I can make an entry. One is accepting, other one is non-accepting. This is BI. Yes, I can make. CI. Both are accepting. So I leave this. DI. I can make an entry. EI. I can make an entry. FI. Both are final. I can't make an entry. GI. One is final, one is non-final. I can make. The last one, HI. So these are the first level markings in the staircase model. So we have done the horizontal entries. After doing the horizontal entries, we will have to do the vertical entries also. So coming to the vertical entries, you see these columns. So here it is CD, yes, market, and CE, yes, market, CF, both are final, no, CG, market, CH, market, CI, no. And come to F, vertical entries. So FG, yes, FH, yes, because this is final, this is non-final, FI, no. So we have done the vertical entries, initial vertical entries. First we do the initial horizontal entries, then we do the initial vertical entries. After doing the entries, we will have to see which are the blank cells. These blank cells, that is AB, AD, AE, AG, AH and so on. This we will have to make the transition table. We will have to prepare the entries for this. That is A on 0 goes to B, B on 0 goes to C, A on 0 is B, D on 0 is E, A on 0 is B, E on 0 is F. So looking at the previous transition table, we will have to prepare this new transition table for the cells which were not marked in the staircase model. Similarly, what is A on 1 is E, B on 1 is F, see, A on 1 is E, D on 1 is H. So you can just go back and see. So what we will have to do is, if any of the cell, for example AC is marked, so if this cell is marked, we will have to mark the corresponding entry. Say for example, check if BC is marked, mark AB. So BC, yes, if BC is marked, so mark AB. Now check either BE or EH. If any one of these entries is marked, then we will have to mark the corresponding entry here. So if BE or EH, BE or EH, BE, no, EH, no, it's not marked. Then BF, EI, BF, yes, BF is marked. So BF is marked, mark AE. So BH, BE, look for BH, no, BE, no, it's not marked. So next BI, EC, BI, EC, BI is marked. So BI is marked, mark AH. Then CE, FH, CE, yes, CE is marked. So CE is marked, mark BD. CF, both are final, FI both are final, so it is not marked. Now you check CH or BF. BF is marked. So BF is marked, mark BG. FC both are final, CI both are final, so no chances of getting marked. Now we check DG, BH. DG, DG, no, BH, no, it's not marked. So AD, EH, AD, AD, no, EH, EH, no. AD, EH, no. EF, IH, EF, EF is marked, yes. EF is marked, so mark DE. Then EH, IH, EH, no, IH, yes. So HI is marked, mark DG. Now EI or CH? EI, yes, EI is marked. So EI is marked, so mark DH. FH, BI. FH is marked. So FH is marked, mark EG. Mean it's already marked. So FI, IC. FI, no, IC. IC, no. FI, IC, no. AG, BE. AG, no. BE, no. It's not marked. AG, BE is not marked. IH, BC or HI is marked. So HI is marked, mark GH. So cross check the entries once again. If any one of these entries is marked, we can mark these corresponding entries. So now I get AE, AH, BD, BG, DE, DG, DH, EG and GH. So let me go back to the staircase and do these entries. AB, AE, AH, AB, I will use a circle. Let me use a different color. Let me take, yes. So AB, AB, AE, AH, AE, AE, AH. So AB, AE, AH, BD, BG, BD, BG, BD, BG, fine. Now BD, BG is done. DE, DH, DE, DE, DH, then EG, GH, EG, G, EG, GH, GH. So these are the level 2 entries. So after doing these level 2 entries, again we will have to repeat the same procedure. So whatever cell is not marked, so AD is not marked, AG is not marked, BH and BE are not marked, CI, CF are not marked, DG not marked, FI not marked. So I will have to make one more table using these entries. So I have kept this ready. Yes. So this is the table. In this table, I have made the same, from this transition table, I need not again prepare the table. So whatever cells it is not marked, whatever rows it is not marked, I just copy it. AD is BEEH, AG is BHEB. Like this, I have just copied in the next table. So by copying that, this would be the new table which we are going to get. From this table, we will see if there are any new entries that can be done. If there are any new entries, we will do it. Otherwise, what we will do is, we will stop at this and we will see the pairs. We will see the pairs. The pair AD, AG and DG. So, AD, AG, DG. So, AD, AG, DG, all these are indistinguishable pairs. So, we combine those three and call it as ADG. Similarly, the pairs BE, BH, EH. We will combine these three and we will call them as BEH. So, likewise, so these are all, indistinguishable because all the states are non-final states, and coming to BE, BH, EH, they are all again non-final states. But coming to CF, CI, FI, these are the final states. So I have taken CF, CI and FI. Combining these three states, we will make one state CFI. So we got these three states ADG, BEH and CFI. Now we will have to look at the transitions. So AD on 0, it goes to BE. So ADG on 0, it goes to ADG on 0 goes to BEH group. So what about AD on 1? AD on 1 goes to EH. AD on 1 goes to EH. So this is 0, 1. ADG on 0 also goes to BEH. On 1 also it goes to BEH. Now let's see the other one. That is AD is done. AG on 0. You can check. AG on 0 goes to BH, which is the same. AG on 1 goes to BE. So, AG on 1 goes to BE. BE on 0 goes to CF. BE on 0 goes to CF. BE on 0 goes to CF. BE on 1 goes to FI. BE on 1 goes to FI. Now, BH on 0 goes to CI. BH on 0 goes to CI. BH on 1 goes to FC. BH on 1 goes to FC. CF on 0 goes to DG. So, CF on 0 goes to CF on 0 goes to DG. CF on 1 goes to BH. CF on 1 goes to BH. CI on 0 goes to AD. CI, this group, on 0 goes to AD. It's already taken. CI on 1 goes to EH. CI on 1 goes to EH. Already taken. DG. DG on 0 goes to EH. DG is here. On 1 goes to DG on 1 goes to EH. It's already taken. DG on 1 goes to BH. DG on 1 goes to BH. It is already covered. Now EH on 0 goes to Fi. EH on 0 goes to Fi. EH on 1 goes to Ci. EH on 1 goes to Ci. Fi on 0 goes to Ag. Fi on 0 goes to Ag. Fi on 1 goes to Be. Fi on 1 goes to Be. So, this table has been reduced and this is the new transition diagram. Initially, we started with A to I as the states, and finally we are left with 3 states. So, this is minimization of DFA using the table filling algorithm. Thank you.